Everybody's Tyler here at the VEXU Purdue Slam and Jam event, checking in with an incredible team. It's Knightmare Robotics from UCF. This team overall, incredible win streak, and 9 awards so far this year, guys, with a triple crown, couple triple crowns as well. This team is absolutely rocking it. They got an incredible set of robots here that we'll be diving more into, and a lot that you can learn from this, regardless if you're in VEXU or V5RC as well too. Couple different options for how they're doing the wall sticks, so focus on that. But they have an incredible 9-step goal rush that we're going to be diving into. They are super quick for the goal rush as well too. We'll be diving in more of their code, some of their anti-jam, what they're doing with that, and a lot more, and just some great custom things that go in, how they're packaging their motors. A lot you can learn here, coming up here on Pits and Parts. And Tony, let's start to dive more into this robot here. Rocking split intakes on it, but I'd like to dive a little bit more into what you're doing for those dunker options, and then some of your packaging with your motors as well too.
Yeah, so we start off, we decided to tackle this since we have 2 robots, we wanted 2 different options. So we run one dunker that is a range dunker, so we've got a little extra height on it compared to our 16-inch bot. And for the 16-inch bot, we run a 180-degree dunker. So we have options set for it to stop at the height of scoring wall stakes and go 180 degrees for it to be able to score on alliance stakes. So that implements our hang. So when dunker goes up, a rubber band is able to passively pull up these hang bars. It just allows us to dedicate no pistons towards both hangs, and overall just make the bots as simple as possible and make tuning as simple as possible for them.
Do you find one is able to tackle the wall stakes a little bit easier than the other?
Yeah, so because mine has a little more range on it, it makes it so I don't have to always have wall stake in this little divot of our aligners. I can have it just like within this kind of range of the wall stake or of the robot. But for our 24-inch bot, because it's a 180 dunker, we have about half an inch less of range on it, so we have to get as close as possible or like push on it a little bit.
Do you find, like from a mass strategy standpoint, do you find that it's just whatever robot is able to get a wall stake closest, that's what you go with, or do you try to preference one over the other?
We kind of try and keep, Matthias will touch on strat-wise, how we try and keep it as consistent as possible, but usually he'll be the roamer in a match and I'll be the guarder. So I'll take control of positive corner, and I practice a lot of good defense while holding goal and protecting the goal in positive corner without double possession. And overall, he's just really good at swerving around people to fight for wall stakes, or just filling goal well, knowing when to go for wall stakes, knowing when to fill mobile goals. So that overall, even though we're using the less range one for wall stakes most of the time, it's still got enough range to consistently do wall stakes.
Let's take a look at your drive as well too. You mentioned earlier you got an 8-motor drive, and I really love how your packaging is for it. So let's show that off and tell me more about it.
Yeah, so we did want to dedicate 8 motors only to the drive, just because there is a 12-motor limit before wattage starts to go down on all the motors when you're using 12 at once. So we decided 8-motor, custom ratio of 19 to 21 to go 542.86 RPM on 2.75-inch Omni wheels. A lot of VEXU teams decide to go custom with their Omni wheels, but we just see the consistency with just regular V5 stock ones. So we just go all custom gearing, packaging the top set as close as possible into the bot, so just there's no contact to it, and to make it just as slim as possible, as well as cutting our screw joints short on both of the front gears, just so we don't have to run in a long screw and the extra weight of that all the way over, since this is protected by a bearing flat on the inside of the C-channel and can keep that design straight overall. Otherwise, the biggest motor packaging thing is we decided to run a 3-motor intake on these bots. So we run split 2-motor hook stage so that we can have a lot of power and aggression for a ring to spin onto a mobile goal, as well as a dedicated 600 RPM motor towards the first stage, so that when we have a ring already set up in dunker, the top stage is locked, and we can still run the bottom stage of intake and still grab another ring even when it's locked in there. Yeah, so that about covers all our motor packaging stuff, and we just try and use 3D prints, not to make everything as custom as possible because of just inconsistency and a whole lot of testing. So we try and use as much stock metal as possible. But wherever we have found that 3D prints do work, stuff like funnels, intake ramps, and the intake itself, just is a whole lot easier and looks a whole lot nicer when we dedicate 3D prints to it instead.
But yes, I really want to talk about this goal rush that your team is running as well too. We were talking earlier, 9 different steps, motions to get into that, but super quick as well too. Let's break all this down.
So because of that custom drive ratio, we have quite a bit of torque to our speed, and that allows our pretty heavy robot with 12 motors on there to move quite quickly across the field. and we use that speed to go get a goal on the autonomous line. But because our robot can be 24 inches long and we're not utilizing all that length, we've added this rush mech in the back, which makes our robot about 24 inches long and keeps us within starting position. But we also have a rush arm in the front. So we cannot use both and still be in 24 inches, so we have to flip-flop. So this one starts down, held by a rubber band and the omni wheel. When we back up, it locks, and then when we drive forward, the rubber band pulls it up. So that's our first motion. That's motion 1. Second motion is driving forward. Third motion is the rush mech goes down, which also holds this. So rush arm goes down, dunker aligner comes up. That's 4 motions. Then we lift our intake. That's our 5th motion, and we turn the intake on. There's our 6th motion. While this is all happening, rush arm comes out, we're driving forward towards the goal, and we intake a ring off of the stack in front of our goal. That ring then gets held inside our intake, and our rush arm picks up the goal on the autonomous line. That is our 7th movement. And then we drop our intake to fully intake that ring and back up, and that is our 8th and 9th movement. So all that happens in about 1.24 seconds to successfully get a mobile goal across the autonomous line into our side of the arena. And we found that it's worked both times today. Pray it works again, but it's been really cool to watch the robot just launch off the line, get that goal, and bring it to our side safely. Both matches so far today.
Something I want to ask you, I mean, going through 9 motions, so when you were coming up with this process for it, did you find that the process just kind of developed itself, or did you come up with those 9 motions and then design based on that?
It really came down to driver preference. We wanted double rings for dunker, and then that was able to spur into a completely different that was able to make this rush possible. So when we have dunker up, like Antonio said, we can hold a ring here and get another ring here. That means we need another motor on our intake. But then that allowed us to not lose our preload because we don't have a goal, and intake another ring off of a stack. So it served 2 purposes. And then once we realized we could do that, we could realize we could start a little bit straighter to the goal, so we were decreasing distance. So that strategy really came from me wanting something more for driver. So
before we pass over and talk about programming side, we got to talk about really what brings the most strategic value to your team, and that's this little car that's on here as well.
Absolutely.
Talking about that initiative.
So one thing that I think is when you feel good, you drive good, and smooth is fast. So one thing that I think is the smoothest thing in the world is a Koenigsegg Jesko. So that's what I have hanging off my bot. Antonio has a Cadillac and no controller, a Cadillac GTP, which is one of the coolest sounding cars in the world.
Good to disconnect. Go ahead,
And we've started handing out cars to teams in our region, and we think it's really fun. And that like when we get to Worlds, we'll see all the teams that we've helped out and mentored, and see the cars on the robot.
Yeah, I mean, honestly, I think that's a great way to just get kind of that cohesion amongst all the teams that show kind of the impact you have as well too. And I think that's something important that a lot of VEXU teams should focus on, is like helping the younger teams, getting them involved and impacted. So congrats to all of you for doing that as well too. Kush, let's talk about some of the programming aspects on your robot. You got some anti-jam code, a few other things you want to highlight. Walk me through it.
Yeah, real quick, I can touch on kind of the library we use just for everything. We use Easy Template. Shout out Jess from Easy Template. You're the GOAT. Real quick, we have 2 odometry wheels, the lateral and the horizontal and the vertical. So for certain motions, we just use PID, and then for certain motions, we do use odometry and peer pursuit. It really depends on our preference. For instance, for our goal rush, we use PID, and then we kill it at a certain distance so we don't lose our velocity, so then it doesn't go to that point and start slowing down. And then our jam code, real quick, it's basically just if it detects a lower velocity than it should be when the intake is running, or if the voltage is getting higher when it shouldn't be, it'll just move up and down to basically kind of free the intake here, and then it would just try to jam out to get the ring out of the jam. And then we also found that it also works when we're doing color sorting. So when it detects the wrong color, it'll activate that just for a couple seconds, so then the ring will just fly off and we can keep moving on without having to deal with a ring still in the intake that we don't want.
Well, Knightmare Robotics, congratulations on a fantastic season so far. I think a lot more to come from your team as well, too, so we can't wait to see your continued success and your performance all the way through the VEXU Worlds as well, too. So good luck, of course, here all the way through, and thanks for breaking these down. There's a lot of great things that I think both VEXU and V5 teams can take from this, so appreciate it. Thanks a lot.
Thank you.